All right, so this is a demonstration of one of the activities that are found in the Community Math Night Toolkit. This one's called Many Ways of Counting. Um, and I'm just going to illustrate what will be presented during the conference. So this one asks children to basically read three things as they work on tasks, to respond to the prompt, explain how they got their answer, and then find another way to double check that their answer is correct, right? So think of a different strategy they can use to make sure that the answer they got was right. Hence the title, Many Ways. So we start with a simple activity. The way this is prompted, and they ask them if they're ready, and then here's the question: how many balls are in all in this picture? And so most children, when they look at this, they might do, especially if they're young, they might just do counting by ones, right? So they might just count one by one. So here's one, here's two, three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, right? So there are 33 balls, looks like, unless I'm mistaken, and that is just by counting by ones, right? Um, and that's great. You can say, yeah, that's great. That's the answer. So, but we again want them to check if that answer was correct by using a different strategy. So, activity will ask them, could you think of another way? Can you double check by using a different strategy? And again, we want to make sure that they have an opportunity to explore a different way to get to the answer, and maybe by exploring some of the features here of the graph. Right? So here we see that these are different balls that are grouped by type, right? So that we have soccer balls here, football, volleyball, basketball, and soccer balls again, and football at the end, right? So these are grouped by the type of ball that's used, and so we could use that to our advantage. You can say, well, I don't need to count one by one. I could just say, well, there are 3 soccer balls. And here we have 1, 2, 3, 4, 5, 6 footballs. I got 3, 5, 6, 7, 8, 9 volleyballs, and then 1, 3, 6, 8 basketballs. Again, we had 5 soccer balls, and then only 2 footballs at the end, right? So in this case, I can group them and just count it by groups, right? And then just all I have to do is add 3 plus 6 plus 9 plus 8 plus 5 plus 2, right? That should give us the same answer as before. And then just we can double check and get the same, we should get the same answer that we did before. And this is just another way to encourage students, children to, think about, what the question is asking, and is there another way, another strategy you can use that can exploit some of the features that are present in the graph, perhaps, make it much easier or perhaps more efficient to find the answer. Then the activity will ask them for, let's look at the next challenge. We'll try it a little bit harder, something a little more difficult. So this here has a calendar, which has the weather for a particular month. And we ask them, okay, how many days has the sun shone in the past few weeks, right? So there's, 1, 2, 3, 4, 5 weeks here. And then we got the sunny days are represented by the sun here shining, and then it's some rainy days as well, right? So again, most children might say, well, I'm just gonna count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I got 28 days that were sunny. And that's fine. That's a perfect strategy. We say, yeah, okay, you got the answer. You show me, you counted by ones. You only counted the sunny days, and out of those, the whole month, you got 20 days that were sunny. That's great. But we will ask him, okay, well, can you think of another way you could get to the answer, right? You can get to that number, 28, by looking at the calendar. So here's an opportunity to think again. Okay, well, if I were to do this a different way, I could say, well, how many days are in a week? Well, there are 1, 2, 3, 4, 5, 6, 7 days each week, right? So each week has 7 days. And then rather than counting the sunny days, I could just say, well, I'm just going to count the rainy days and take that from the total number of days. So in the first week, there was only one sunny day, rainy day. And then the second week, there were 2 rainy days. There were also 2 rainy days. On the third week, 1 rainy day on the fourth week, and then also 1 on the 5th week, right? So now I can say, well, every week has 7 days, and I just take the rainy day out of the 7. So the first week, there was only 1 rainy day, so that will make 6 sunny days. Then the next week has 2 rainy days, so that will make it 5 sunny days. Same for the next week, 5. And then 1 rainy day on the 4th week, and then also 1 rainy day on the 5th week. And then we just add this, so we got 10 here, and 6 and 6 is 12. That's 22 plus 6 is 28. And that's the same answer we got before, so we know this is correct. And again, it's just trying to have children exploit some of the features that are present in this case in the calendar, and try to think of a different way that they can do counting that will use the knowledge of numbers, the knowledge of operations, and use that to their advantage, right? So here we got the answer right. Now we also had to think of, okay, well, let's increase this difficulty and think about, higher grade levels when they start thinking about, counting, and thinking about now thinking long down the road, when they start thinking about maybe probability, and they had to learn about, the probability of certain events for happening versus not happening. So one way to do that is, thinking about the combinations, right? Thinking about permutations, combinations, things like that. It's part of combinatorics. So this one can ask how many pieces of clothing all. That's pretty easy. You can just say, well, just count by ones. I had 3 here, 1, 2, 3, and I had 1, 2, 3, 4. So that totals 7, right? So there's 7 pieces of clothing. That's pretty easy. But then we say, well, let's challenge you a little bit. If we say that an outfit consists of 1 top and a bottom piece, how many outfits are possible? So at this time, I had to do something different. So this time I'm combining things. So I say, I take this top here, this green sweater, and then I had to say, okay, I added the jeans, so that's 1 type of outfit. If I had dress pants, I have another one. Or if I had these purple ones, I had this, or this shaggy brown pants here, that's a 4th one. So if I use the green sweater plus this other 4, I get a total of 4 outfits. If I had a yellow t-shirt and do the same thing here, I'll get the same, I'll get a number of outfits, I'll get 4. And if I use the black t-shirt instead, again with this 4 here, I should get 4 also. So in total I have 3, so I have 1, 2, 3 times 4 number of outfits, which means I have a total of 12. So that's the total number of outfits I could come out with this, combining tops and bottoms, right? I got 12 outfits. So that's just another way to challenge students to start thinking about, beyond just counting by ones or counting how many in a group, thinking about combinations, permutations, things like that. The next thing is we ask students to create their own activity. So this is an opportunity for them to come out with their own. So this is a blank canvas, and they can decide to just write down, what they want here and that gives an opportunity to work on that. So that's just a very brief example of what we plan to do during the conference to show them, you know, demonstrate the things we can do in a Nearpod and try to adapt the type of community math night toolkit to a virtual environment. Thank you.